So he works at Weta and he's going to talk about fixing Python. So here we go.
Cool. Yep. Yeah, thanks everybody. My name is Teijo Holzer. I've been working for Weta Digital in Miramar for 7 years now as a production engineer. Weta Digital is a VFX house. We do visual effects for movies, Hollywood movies, Peter Jackson's movies. And I've been working mostly on Python, but also some other languages at Weta. And the infrastructure that we have at Weta is quite unique in such a way that we have a large number of computers and we run lots and lots of processes, sometimes millions or even tens or hundreds of millions of things a day. And therefore, we come across problems that other people don't normally have, or only very large companies like Google, Facebook, and Twitter, and people like that have. So today, we're just going to talk a little bit about Python, the problems that sort of I came across in Python standard libraries, and the way of going about fixing these bugs, submitting patches to the maintainers of Python, how to get the patches accepted into the mainline trunk and integrated as well so that other people can benefit from that. The talk will run for maybe 15-20 minutes, and then after that there will be some time for questions as well, and you can ask me some questions. Okay. Yeah, so we'll start pretty much very simple Python program. Probably everybody knows it. Print hello world. That's usually how you start learning a new programming language. You just develop a hello world program. And the heading for this slide is every program has bugs. So even the hello world program that you see in front of you that has bugs, we will demonstrate that as well, what the bugs are, different bugs that it has, this single line of code. And that is the important thing to keep in mind, even though you might look at a statement and think, oh, this statement can possibly never fail, you know, why should I worry about this? It's such a simple statement. The things that we do at Weta make these things fail on a regular basis. The next slide, this surrounds the print hello world statement with a while one loop, or while true loop. So basically what this means, it instructs the computer to print out hello world and ad infinitum, which means endlessly. It just keeps on printing that. And you go like, this is clearly insane. You know, why would you want to do something like that? You do something and you do it over and over again, and you expect a different result. But again, at Weta, we do things over and over again, and sometimes they fail, and you go like, oh, that's very strange, because it used to work 1,000,000 times, but then it fails one time, and you ask yourself, why does it fail? And these are the kind of constructs that you normally use. You can find that this program, print hello world, you run that once, it works fine. You run it 100 times, works fine. Now you run it 100 million times, and then it starts failing, and you go, okay, so now we have issues with this particular statement, you know, because you just do it so many times, you do it so often, you know, and it fails. So now I'm going to show you how this can actually fail in various different ways. We'll start very simple example, just a bit of a background. At Weta, we use mainly the Linux operating system, so most of these examples that I present now are from the Linux operating system, but some of them can actually be applied to Windows as well. But it's mainly Unix-based operating systems that we're sort of focusing on here. Okay, so this is now the first failure of our hello world program. The test program is what you just saw before with that simple while loop. And we pipe that, this Unix pipe symbol from the shell, into a command called head. Now the command head is a standard command on the Unix operating system. It literally just prints the first line, n-1, and then finishes, you know. And you can see it prints the first line, hello world, and then you can see the traceback from the print statement. And the error that you get is the IO error, error number 32, broken pipe. Now why is this? Why is the print statement now failing? The print statement there is not writing to your terminal or console, because we use the pipe symbol. Now the pipe symbol means you redirect standard out from that Python program. Instead of to the shell, you redirect it to another command, in this context, head. Now head is only concerned about the first time hello world prints, and then it exits. Therefore, the pipe is closed, and you get that error called broken pipe. So what that kind of shows you is that yes, print hello world can fail, And also that sort of should make you think twice of using print statements in your code, because depending on how your program or library gets used, that print statement in your code that you left in for debugging purposes might actually cause the whole process to fail, because in this context, this process that should run forever fails after the second, or at the second print statement. So that's just one example of how you can make the print hello world statement fail. We move on to another example. So that was with the help of a pipe there, which is not that uncommon. You pipe output to other programs, and then you process them further, and if you're done processing, you just exit. Now this is the same program again, printing hello world. Now what that does, the syntax you see up there is a redirect symbol, and it redirects, this is a bash syntax by the way, it redirects to a port. Now it redirects to a port on localhost port 22, and that's usually the port that the SSH daemon is listening to. And you can also redirect it to port 80, which is the web server. And now what you get, the print statement again fails. It's a different error. It's still an IO error, but you get a different error number. Now the connection reset by peer. Basically what's happening here, the Python program prints hello world a number of times, and you can actually measure that, how many hello worlds it gets through before it fails. It's around 680 or so. So you 680 times your hello world print statement will succeed, and the 681st time it will fail, exactly with that error, because the SSH team is saying, what are you kind of sending in here? This is all crap. I can't even pass any of these requests. I'm expecting some SSH handshake, and you're sending hello world. Just go away. And it closes your connection. And and your program receives that, and you get that particular error number back thrown at you in that print statement again. So you can see, again, print hello world fails in that context. Again, very important. It's a different failure. It's still an IO error, but it's a different error number. So you can catch both of those with the IO error. So there's two examples where the print statement hello world can fail, and I've got a third one as well. Now this is a bit of an obscure construct up there. Again, this is bash syntax. We run the Python test program, and this redirect ampersand dash construct there at the end that you see means it's a shell construct from bash. It means close the file descriptor associated with standard out. So we're simply closing standard out. Okay, that's obviously a mean thing to do, because the print statement tries to write to the file descriptor that is standard out. But this is not very uncommon for things like web services, daemons, processes run in a particular kind of headless environment without a shell attached. So closing the standard out file descriptor is not uncommon for daemon processes that run like web services. So in that case, if standard out is closed, your print statement again will fail straight away. Oh, okay, now backtrack a little bit. Your print statement will fail. Now again, it's a bit coming back to that while loop. It's not the first print statement that fails, because standard out by default is buffered, which means the first print statement will not cause the write to trigger onto standard out, and thus the failure will be postponed until you have enough in your buffer. Again, there's a few hundred times that you can write hello world to close file descriptor before the flush will trigger, and thus causing you the bad file descriptor. So I guess the thing I'm trying to show here is that even a simple line like print hello world, or a print statement in your library, in your program, or whatever, can cause your program to fail and your process to die, because that's the end result of it. Because if you don't catch it, you will simply die, and then the process has finished. So what do we learn from that? I guess surround your print statements with try except, or even better, use the Python logging framework. It's even better for that kind of stuff, because that actually catches the exceptions, and you can choose to even ignore them. There's a setting for that one as well in the standard logging API, so that's much better than using print statements that can fail in various different ways, like we've just demonstrated. So moving along, fixing the standard library. So the title of my talk is Fixing Python, and what I've done a few months ago at Weta, I came across a problem in the standard library temp file. Temp file is a standard Python library that allows you to safely create temporary files on disk. It had a particular problem that I came across during my time at Weta. And I thought, yeah, this is a problem there, I would like to fix it, but I would also like to provide a patch and have other people benefit from it. That was the first time I tried to do that, and I was surprised by how quickly that was actually accepted and how quickly it was integrated into the mainline chunks of the 2.7 and 3.4 branches of Python. So temp file named temporary file, it's a constructor or your function call, a method call that creates a temporary file on disk. It takes a mode argument, so you can pass it in if you want it read or write. Now, if you pass an invalid mode into this function, it triggers that bug, the bug that I've discovered. And the bug is a subtle one. It's a file descriptor leak. Now, a file descriptor leak basically means if you call a function, the function returns with a failure, of course, because you have passed an invalid mode into the function. But behind the scenes, there's a file descriptor that has open. This particular call has opened, but it hasn't closed, right? So again, that comes back to that while loop. You do that once, nothing happens. You've got a leaked file descriptor. You run that inside a daemon or a web service, and over time, you build up these leaked file descriptors, and eventually you run out of file descriptors. There's always a limit. You can set those limits. They're usually 1024. I mean, you can set them as high or as low as you want, but eventually you hit that, and then you have problems because then you cannot open any more files at all. So this is a particular nasty bug, whereas the problem is in that particular library. However, it might show up somewhere completely unrelated because any subsequent file that you try to open once you reach that limit will then fail. So any new opening in somewhere completely different, unrelated part of code will cause that open to fail. But the cause was actually in that library. So we'll have a look at the test case now for this. Again, it comes back to the insanity of doing one thing over and over and over again and expecting different results, and that's exactly what we're doing here. So we've got an infinite loop. By the way, this is what I recommend if you write a particular function or class or method. Simply put it in a while one loop and let it run overnight and see what happens, you know? Because that's a very good way of flushing out problems that occur when you do things over and over again. And it's not unusual to expect these things to happen. Again, you can do that as many times as you have open file handles limit set, so 1024 times. This will succeed, this while loop, because I'm catching the value error for the invalid mode, demode X. And then eventually it'll throw an OS error back to you saying that you have too many open files, you know. So that is the actual bug, you know. This shouldn't happen. I should always get back the value error and the while loop should continue overnight. You know, that was what I expected. So I said, yeah, let's go and address this and see if we can fix this problem inside temp file and provide Python with a patch and hope that they can integrate it. Okay, this is a patch. It's really simple. This is inside the libtemp file, so there's a standard Python library. It's written in Python. So there you can see that there's the fd open with an open file handle in the mode. And all I did is just surround that by try except and make sure the file descriptor is closed and raise the original exception. I mean, that's really the only thing here. So this is the actual fix. You know, you catch the exception, you close it, and then you raise that value error that goes back. And therefore, you avoid that file descriptor leak in that particular part of the standard library. So that's the patch. So I went ahead, I created myself an account on bugs.python.org. I've submitted the bug report. I've provided a test case. That's very important. Every time you discover a bug, see if you can provide a test case as concise as possible as you can, because that increases the chances that your bug report gets accepted, right? It's really important that you have a reproducible test case that people can just cut and paste and say, okay, yes, this is valid, this is a problem, and this is how I can reproduce it. Because only if you have a reproducible test case can you verify that your patch has fixed it. That's very important. Yeah, because if you have an intermittent problem and you don't have a reproducible test case, you can say, oh, I think I fixed it. I don't know. We'll put it in production and wait another month and see if it happens again. And go like, no, do it like this, and then you know you fix it. And indeed, I did that. I fixed it. And then this OS error didn't happen anymore. So that was the test case. Very important bug report. Of course, report the bug, test case. If you can, provide the patch. Increases the chances that somebody will actually have a look at integrating it, because half the work's already done for them. You know, they can just verify it, put the patch in, run their unit tests and integration tests or whatever they have, and then see if it works. So that's the patch for that particular bug that I've discovered. Okay, so these are the steps that you would go through. Yeah, go to bugs.python.org. You sign up. Also very important, search for existing bug reports. Chances are somebody else has already discovered the issue that you came across. See if people are already working on a particular issue, or if there's already discussion around that issue. If you can't find one, submit a bug report, test case, and the patch if available, and wait for the reply and adaptation into the main branches of the Python release. The Python releases. So yeah, I have to say I was actually positively surprised, because I've never actually submitted a patch to python.org or via bugs.python.org, and the turnaround time from me submitting the bug report with the test and the patch until they actually fixed it and merged it into trunk was 5 days. So amazing turnaround. Obviously it took another 4 months or 5 months to release it, because they have their release cycles. But now in the latest release, the 2.7.8 and 3.4.1, this patch is actually in, so it's been out for like 2 months or so in the latest versions, and it's in the changelog as well. So that's how you could go about if you want to submit something, and that applies to other open source projects as well. It's not just limited to Python. It's just I use Python as an example because it's a Python conference. All right. So summary: every program has bugs. I guarantee you that. Even print hello world, yes, it has bugs, many bugs. You can fix them. You can anticipate them, and you can fix them. You can help out by improving Python. Obviously, that makes a difference for other people that might come across the same issue. Say, yeah, this is really weird issue that we have with our long-running services. We run out of file descriptors. And you go, okay, maybe it's related to that. Always provide a reproducible test case. Very important. And yeah, that's the issue number in the bug repository database of Python, which has then been merged into 2.7.8 and 3.4.1. Coming back to that first statement as well, we have a very large render farm at Weta Digital, so we have a large number of machines where we run our automated procedures, rendering processes, and then things like that. And these machines constantly fail. It's always like that. If you have one machine, obviously you can concentrate and you just run it and you expect it to work. If you have 5,000 machines, there's always machines that are down, that are on its way out, and you have hardware failures, different types of hardware failures. Could be hard drive failures, could be memory failures. So even an assignment, when you look at an assignment, you say 1 + 1 must not necessarily equal 2, because if you have memory problems, if your memory is flaky, then 1 + 1 might as well equal 3, So you can never guarantee that even a simple statement like 1 + 1 will actually give you the outcome that you expect. But these are kind of hard to debug, these kind of problems, hardware problems, But this is a particular software problem. That was my talk. I'm open to questions. Feel free to ask anything you would like to know.
Does anyone have any? There we go.
I'm quite interested to know why your program was trying to open files with invalid modes in the first place.
Okay, the reason for me to go, I cheated a little bit here. We had that discussion at work, and I said, how do you create a temporary file? It's hard to do it correctly. Some developer and team said use a temp file, and I go like, no, it's buggy. And he goes like, why is it buggy? And I said, I open it up, looked at the source code, and say, here's the bug. It's a file descriptor leak. Let's provoke it. So it was the kind of roundabout. So I cheated a little. It is a valid bug, because it has been accepted. But I looked at the source code. However, the glibc extensions to fdopen or fopen allow a mode of X. I forgot what it actually does mean, but it is an additional mode that glibc supports, the underlying glibc call. However, the Python API hasn't adopted that because it's glibc specific, so it's not POSIX, so it's not available on all operating systems. Yes, but yeah, if you want to discover bugs, the easiest way I found is just to read the source code, because it's pretty obvious,
Anyone else? Feel free.
I heard you saying if there's something weird going on, let's have a look why it's really weird. I would like to share a little bit of a war story on that topic because it is fairly, I wouldn't say it's fairly common, but it happens, especially in small businesses, that people usually take the shortcut and say, oh, we are just restarting our servers overnight, which is obviously not solving the real problem. So I would like to encourage everyone who has this nagging feeling to know what really is going on there. If the company is not financing the time to look, just do it for yourself, because at the end of the day, you'll be better off and you're much smarter knowing what is really going on, and you might end up providing the patch. So
yeah, no, that is correct. I fully agree with that one. It's really important to monitor your programs and your processes, and ideally you will get a full report every time your process crashes. We have set up something like that at Weta as well, which provides a detailed report when it crashed, what the reasons for it, if stack traces standard out and all that kind of stuff. So as much information as you can collect as possible, yeah, and I fully agree with that, because then you have much more robust systems in the end. Yeah.
And that learning will help you get a job at a company which will pay for your time to find things. I just wanted to say, isn't it arguably a bug that it opens a file descriptor at all if it's going to reject the mode?
The problem is that the FD open call that we saw on that slide, this actually just binds the open file descriptor against a file object. So the open actually happens further up, because that FD is already an open file descriptor. Hang on a sec, where are we? Oh yeah. So at this point, FD is already open. The actual open happens further up. It's not shown on this slide, So it opens a normal file via the open call, and then it tries to bind it to file descriptor via the FD open call, and that binding fails, So that's why, if it's only one operation, you're correct. Then the open would fail, and then you haven't leaked the file descriptor. But because the open is separate from applying the mode, you got a two-step operation. You have to have that rollback. Yeah. So yeah.
How have you found the relationship with Autodesk while reporting bugs with PyCon and stuff like that?
I've found them responsive. We have a good working relationship with Autodesk, and found them responsive to my concerns. I've raised a number of bugs against Maya and issues within Maya, and also related to Python within Maya with Autodesk, and I found them quite responsive, even to the point that they've called back and discussed the issues with me, and then providing reproducible test cases and then getting replies from the engineers. So yeah, positive experience there with Autodesk. Yeah.
Anyone have any bugs in Python that they want to talk about? Would you like to wrap it up then?
Yeah, okay. Thanks everybody for coming, and yeah, keep up the work and provide patches to open source projects. That's